Hi, everyone. Welcome to a fairly brief design review of some 14.3 functionality for Wolfram language. All right. Feature extract. What's the question?
Okay, so quick recap of what we decided last time during the meeting. Feature extract with a bunch of examples will keep doing what it's currently doing.
Yep.
But feature extract with a bunch of examples and an extractor will avoid steps that make it input dependent.
Yeah, of course.
Like
That's what we
dimensional
discussed.
reduction.
Yep.
Exactly. Yeah, this is the recap.
Right.
You can always pipe the dimensional reduce vector after it, so no problems. One thing that is enabled by this is also feature extract with a single example, comma image features.
Of course. We discussed this.
Exactly. And then final thing we discussed, be aggressive with default parameters like color space, bitrate for conformation. So we don't need training for those as well if you don't have a training set. So this is a summary of like new changes that will happen.
Okay, so what is the question here?
Okay, questions. Some changes that we noticed while looking at this stuff. If you scroll down, structure preservation. Right now, the assumption is that you want a feature vector always. I think sometimes we don't want to distract the input. So here, for example, we have a tabula. Yeah, if you want indicator vector on the nominal columns, I don't see why this shouldn't stay a tabula. I think it's much better for pipelines.
Well, I don't understand. The indicator vector, I don't understand. Why isn't this just turning every row into a feature vector?
Because by default, only the extractor that applies are applied. So indicator vector only works on nominal data. 29 is a number, 3 is a Boolean.
So
there's nothing to do
the
there.
Structure of the tabular object, just changing particular columns, correct?
Exactly, but I think that this output here is not useful as the second output that I'm
putting. It should go tabular to tabular.
Okay, perfect. So
data
I think
set
we
data set, association to association.
Perfect. We all agreed on this. So we are going to use feature names in this case. Column 1, column 3 for the new columns that are merged by this. But
hold on. Hold on. Who said columns are getting merged?
Well, indicator vector is making an indicator vector of all the nominal columns. This is the current behavior. We could change it to apply it to individual columns.
Well,
but that also
there's a way of doing that explicitly.
There is a way of doing that exactly, which is the second point I have here about feature preservation. So, let's say that you only want to apply indicator vector on sex, for example, here. Now, the thing is the current design took one choice, which I think is not the right one, and which is like drop all the other columns except the one you're processing. If you do want to keep them, you have to force an identity extractor. Right. I don't love this. It's a bit hostile. So I have two ways out.
Which design? The design that we have not yet implemented.
But this is the current. The current design documented is that if you say sex goes to integer vector in this case, all the other columns are going to be dropped. You are effectively doing feature selection by not mentioning the other columns. I think this is a bit of a break with respect to what we had above. Like if you don't put the column, everything goes through, even stuff that is not processed. If you do put the column, like this one here, you drop the other columns.
What other functions do this thing of operating on one column and dropping the and passing through the other ones?
The passing through is very specific of machine learning stuff because we have data types. It's not very common at all.
So what's another example?
Well, I mean, I don't think there are many. Maybe there are none. Like this is how classify and predicts works internally.
I mean, transform columns does that. A transform column, you transform one or a few columns, but the other ones hang around.
Exactly. I mean, we have transform and construct column. I have an example below.
That we have those two examples, two different functions.
Exactly, to keep or drop.
I think you want both in this case as well. And I don't quite understand why you're not then using feature extract. I mean, it's a question of the default for feature extract, because I would have thought that you would use construct columns or transform columns, what is the way of using feature
Is there?
extract?
I put it at the end.
I see. You have to have that column-wise thread.
I mean, with the new syntax, you could also not have column-wise thread. But
Which
I
new
didn't have
syntax?
the fact that you work on a single example that we had above. Yeah, you could drop the column-wise thread.
Okay.
It will be more inefficient, but it will still work.
Well, that's a different issue to make it efficient.
Exactly. But it will still work. So this is just to work in the current version, basically.
But you should make sure that it can be made efficient, because we can see enough information here to effectively do the column-wise thread. See what I'm saying?
Yes.
I mean,
You could compile it. Yeah.
right. And in this case, we could have multiple columns that are combined together to make a single feature column, right?
You could use construct column, for example, to
No,
add,
you could in this
or
case.
even transform column and add a new column says, like indicator
Yeah,
vectors,
right.
and do it on multiples. Yes, exactly. So if we don't want to break backward compatibility,
hold on.
Yes.
Hold on. Okay. This is a default case. I don't think this case, you're going to need both the transform columns and the construct columns cases. So what we're talking about is only the default, correct?
yes.
Okay. All right. So when did we document the current default?
When at the beginning, I think.
At the beginning of what? Of history?
Of feature extract, yes. The
Well,
function is experimental.
Tabular. We didn't have tabular until this latest version. So,
No, but it doesn't matter. I mean, this, if you do normal of tabular, you get something that was supported already.
okay, but wait a minute.
This is the same.
Have we documented the behavior with tabular?
No.
Okay, so we can do whatever we want with tabular.
Yeah, but it would be a bit weird that you drop
Wait a
columns
minute.
in one
Wait
case.
a second. Wait a second.
Yes.
Okay. What has been documented is, explain to me what aspect of this has been documented.
The fact that if you write a column and a feature extractor, all the not mentioned columns are dropped. We don't say anything about the input.
Okay, but in what scenario? We haven't had columns before tabular. What are you talking about?
Well, an example in machine learning is a vector of features. Yeah, so it was always a tabular-like structure. A vector with an image, a number.
Okay, but let's be specific. Okay.
Yes.
If I give feature extract a list of lists as its first argument.
Yes.
Okay. No, let's say I give it a list of associations. This syntax where I have a key from the associations in the second argument, has that been supported before?
Yes.
Okay. And what did it do before?
It drops everything else except for that key that is processed.
Well, I think it's the right thing for it to do. I mean, I understand your argument that it might be nice, but I think both cases are possible things to do. And this is more consistent with a function that's called feature extract that just does that. It doesn't say feature dust, so to speak.
Okay, so maybe we could support between the two things of adding something to drop columns and the other that I have here, we could add an underscore syntax so you don't explicitly have to list all the other columns if you want to keep them. Okay, that's it.
Okay.
Now we can move to the fitting thing.
Hold on. Let me think about that for a second.
Yep.
Whether there's any other way. I think that's really weird because that has nothing to do with feature extraction. The blank arrow identity has nothing to do with feature extraction. It's not a feature being extracted, really.
This is not a new syntax. You see the one above. Class H survive goes to identity. This is works in the current version. And it's even documented that way. Like use the identity extractor if you want to preserve columns.
All right. Okay. Well, maybe we can support all as well as underscore.
Okay, I like all. Yes.
Okay. All right. Fair enough. Let's go on.
Okay.
Where am I going? Which one?
No, you keep scrolling and you go back to the, yes, here.
Okay. Okay. So
Okay.
okay. What are we talking about here?
Okay, I mean, we stopped here looking at these functions and what they should do and what they should output.
Okay, but we're not ready to do the whole revision of everything. We're just introducing. What are we introducing here? What are we going to?
So this first of all, the name for the second one, I think we came up with last time. Kernel model fit, I think, is a better name.
Yes, exactly. Sorry, it's not in the name, but we rename that to kernel model fit.
Then, to be consistent right now, I think it should return a fitted model, and where the actual model is happen to be an interpolating function.
Yeah. Okay.
Okay.
I agree.
And that's consistent with what we have been doing. We can then extract a model with an uncertainty as one of the properties.
Yeah, but that's a horrible design. I mean, look, if we're going to go
No,
to
no,
a
no.
general model fit.
Yeah, but the other thing is that we even want that anyways.
Okay, look, listen, guys. If we're going to use model fit as the future name for this whole collection of things, we do not want to burn local model fit. I mean, we've already got linear model fit, right? That's already a thing. And it returns what it returns, right?
Yeah.
And what it returns is a fitted model, correct?
Correct.
I
mean, just to give you some context, the one below that we renamed to kernel model fit, in the end is a linear model fit. So that will return a fitted model with a linear model. So there's no issues there. This one here is the only one which is like very different in terms of what it's doing.
Look.
Because it's local polynomial fitting.
I understand, okay? Look, what we think we're going to, in the not very distant future, is a situation, so future here is we're going to something where we have model fit, and we have a model spec, and data, right? And where we're returning from this something which might be called fitted model, but let's for now, let's say model fit result. I don't like that very much. Which contains the instance model. And then presumably that's one property here. And we can say model fit of model data, and then something like fit function or something. And that would then return a raw function that will take that takes, xi values and returns the fit results, correct?
Right. Like an inference, yeah.
Right. Okay. And then this model fit result might be renamed, contains the whole shebang of different kinds of things here. Possibly it will be somewhat lazy and things will be computed only on demand.
And one of the things you could do here, instead of saying fit function, you could have an uncertain fit function, which would have the around notion. Like we do now, like we're starting to do now.
Sorry, say that again.
Just as you get a pure function that just, number in, number out, you can have something that gets number in and a round out, like we do now.
Yes.
Okay. So that would allow you workflow-wise to easily plot those confidence bands and other things.
Sure.
So there's around fun of X, mu of
Right.
X, comma, sigma of X, basically.
I mean, this is, I don't know. These are bad names, but fit around function.
Something like that. But what we're proposing now with the evolving existing design framework is not incompatible with this.
Well, it is if we have local model fit. I mean, so linear model fit returns right now a fitted model, correct?
Yes.
Yeah.
Which is not compatible with this strategy.
It's not super incompatible either, because you could request what you want out.
Yes, but I mean, we've either got to change linear model fit to return a model fit result, or, which I think is probably the right answer.
That could be subsumed in the new framework.
What could be subsumed? I mean, we could have
linear model fit. It's going to be a subset of.
I know, but I think
but it still needs
to have that function.
It needs to work, though.
It will. It will.
Okay.
No, but I suspect we should change linear model fit to return a model fit result, and we can have everything. We could even have. We could certainly have the properties still work. So if you say linear model fit, you take the result and you use one of the old properties, that could still work. The hack where you can also give a value of X, that's less clear.
Yeah. But either way, I don't think what we're proceeding on now is incompatible or inconsistent with that.
It is because if we say kernel model fit, right?
Yeah. And that's the other one. Yeah. Local model.
What's this one?
Local model fit. The other one down there, that would be kernel model fit.
That already turns a fitted model. That's effectively a linear model, so it's not very problematic. It's not really changing the bar here.
No, it's compounding the existing issue that we're going to have to change from fitted model to model fit result at some point, unless fitted model I don't know. I don't see, these functions, if we introduce them and they return fitted models, we're just going to have to change.
Yeah.
We could also change what fitted model is doing.
Well, then maybe model fit returns fitted model.
Yeah, that's a possibility. Which is already an object that can be queried.
Yeah, but
and can support legacy properties.
Query. This hacky query, which is the fit function query.
No, yeah, but we can extract it. We can have a property to extract it. The new fit function.
What? That would not be the right thing to do. No. So that we usually get the cruddy old one, and you have to use some special incantation to get the real one. That doesn't make any sense.
No, we were discussing about you get the object that can be queried, or you get the model that can just work on inputs. No properties.
I mean, the design you do here is very similar to what we did with hypothesis test, for instance. Like, again, there's sort of two goals. Either you want something for a program or you want something for a report type thing.
You know, possibly what we want. You know, model fit function could return the pure fit function, like value in the case
Yeah,
of,
that's another way to package it instead of having an argument. And
well, yeah,
that's
but I mean, it's an alternative to the argument. You could use the argument if you want to, but this is
no, I agree with you. I don't think that that's a bad idea at all, because I think it's it's like what we did with optimization. Remember, so we have min value, argmin, and so one to extract the value, one to extract what the minimizing x is, the argmin. Do you know what I'm talking about?
yeah.
Okay. And those are basically, I mean, there are some shortcuts you can do when you compute them sometimes, but in a way, they just pick certain things out.
Yes.
But they compose nicely in code. That's the point of it.
Yeah. Okay.
'Cause-
What are we trying to decide right here?
Well, I don't think we have a problem if we continue like what we plan to do. Local model fit just needs to return a fittle model, and with the other things that can be queried.
Okay. But then now this,
What are you doing there?
well,
Well, you
what is-
shouldn't have to do that. That's
No,
what
no.
they-
This
this is-
is
this
what we
is-
do right now.
that
This
is
is to
not-
show.
This will be
Exactly.
automated, Stephen. It's not going to
so,
have
but
to
what
be
would you do in the future?
You would get
Let's
this.
scroll down.
We get this around thing, and it will automatically plot.
Exactly.
Where is it? Did you have it
Yeah.
here? Or?
Yeah, keep going. New fit properties, error
Okay.
bands. Okay, so this we need to decide a bit basically how to call it. So right now we have a bunch of properties that are like this. We are at the end basically. We have a bunch of properties. Some of them which are like kind of all related in a sense. Best fit is the what could be considered like the default. It gives you the expression, the formula. Then we have mean prediction bands that gives the confidence bands for the mean prediction, which is a list of two expressions. Then we have mean predictions, which is the confidence bands as a numeric list of pairs. Predicted response is basically the numeric equivalent of best fit. It gives you the computed like y values. And then you have the same thing, single prediction bands and single predictions, because the mean prediction is the error on the mean, and the single prediction is the error on the point. So you have formula and data. Now, to do efficiently some plotting, you need something which is, with the current terminology, is best fit plus minus mean prediction band minus best fit. Yeah, and this is what we have added. We need to figure out basically a name. This is what you were calling before fit around function or whatever. And ideally, you have two versions of this. One with smaller error bands that depends on how many points you have. That is the error on the mean. And one with larger error bands, which is the error on the single prediction. That doesn't depend on how many points you have.
Yeah, I don't understand. I mean,
So look here. Look at that picture. Disregard. I don't know what the pinking is from, but look at
the highlighting. But yeah.
Okay, so look. Do you see that smaller
oh,
band?
I'm sorry. Why does it pink?
I don't know.
It should be no. Hold on. It's pinking because you have something dynamic, and this is this crazy nonsense with visualization functions that try and reach out for dynamic stuff, and they really need to not do that. The dynamic thing is a luxury, so presumably with interactive to false, it just won't do that, right?
Right.
Is that correct?
Yes.
But we got to make sure that it never ever does this.
Right.
Never ever does this. Legend dump, whatever the hell it is.
Right.
Okay, so let's add this to the graphics improvements discussion to make sure it never does this. So we make sure that the code never asks for dynamic content that could not be present. In other words, it never asks for any dynamic content that isn't already contained in the actual structure that represents that visualization. Does that make sense?
So you have someone here that takes notes and passes that on? Or?
Mirage, do that, please.
Yep, I will.
Okay.
So can I explain though?
Yes, go ahead.
Okay. So the two things I want to explain. First thing,
Yes, Roger. Hello.
my stupid auto muting. Sorry about that. Okay. So two things that Julia talked about. One less important than one, I think more important. Do you see the two bands around the curve?
Yes.
Okay. The tighter one is what he called mean prediction band. That's basically like the confidence of how well the prediction thing is done.
Yes.
The other one,
It's the data.
yeah.
I get it.
And so most
But I
people
hate
would,
calling it sample. That was something that, Fisher invented in 1931 or something.
I think we shouldn't call it that either. So if you have a good name,
Yeah. So we just shouldn't do that.
okay. But the band I would want to see if I do this is the bigger band that includes the data. If all the data is outside, I would be very unconfident that this even captured the right thing.
Yeah.
So now the way we want to package it up so that it can work nicely in the workflows in the system is as an around f of x, or mu of x, comma, sigma of x. Do you know what I'm saying?
Yeah.
So if you evaluate it, assign variables and values, both of those things evaluate to numbers and you have sort of a regular around. But this is an around function as opposed to an around value. Can you see that up there? It's hard to recognize these arounds when they are.
There's a little gray, like the plus minus on the second line.
Yeah.
Okay.
One line of function and 2 lines of standard deviation.
Okay.
So this is the symbolic form of it, and
Yes.
and plot is going to be able to eat it and do this plot that we have here.
Exactly.
That's nice. That's very
Isn't
nice.
it?
So that is really nice. So I mean, the fundamental thing, does it work now? Is if I say around x,
I'm not sure.
Square root of x, for
Yeah,
example.
try it. Let's see.
Okay. X.
Yeah, I don't know if this is in prototype already.
I don't know. No.
Not yet. So it doesn't. It doesn't.
Okay.
It doesn't
But that's
fail,
really
but
nice.
it doesn't.
That's really nice to be
Isn't
able
it?
to do that.
I think
Yeah.
that's super nice too.
Right. I mean,
Because
we already have
what a
list
pain
plot.
in the ass it is when you have to manually do this yourself.
Sure.
You're going to have 3 curves. Then you're going to figure out colors and styles and fillings and God, horrible workflows.
Okay. So
Yeah, this is going to be like that.
that
Right.
already works.
And actually, if you do list line plot, it's going to join them. It's going to be a little bit wonky, but
You have to say what they have above interval markers bands,
okay.
which maybe should be the default for list line plot.
Probably. Well, I guess you can argue both ways.
No,
there.
I think this is a good. This is a good default.
Yeah.
What is it? Interval markers.
Bands. Number 3.
Okay. Yeah, I think it's a good default, but okay. So the key thing here is that you're able to plot these arounds. So now the question is, how do you return the arounds? I don't really understand any of this stuff. So the best fit, I mean, these are really terrible names. Really.
Yeah, they're not.
I mean, we have obsoleted a bunch of old names, so which they still work with the message.
But this doesn't make any sense. You don't
names.
even want this, the confidence bands. You just want an around. You just want to return an around whose first argument is the fit and the second argument is the 95% confidence.
Yeah.
What about the 91% confidence interval?
No, that depends. There's an option which is called confidence level. You see, I have it there, like model. I call it.
I get it. Yeah, I get that. Okay.
Confidence level 0.95, and you can put whatever you want
there. The prediction, I mean, if I give the confidence level, I don't understand what the mean prediction is.
Well, okay.
No,
so
that was
is that a legacy name?
That was my mistake. When I proposed a name mean prediction before noticing that there was mean predictions. So I mean, we need to decide names basically.
Okay, but okay. So look, the first thing here is presumably best fit function. Is that correct?
Right.
That's already there. It's called fit function. The one that is
What
a
do you mean by
function.
it's already there?
No, I mean, that returns a pure function, doesn't it?
Exactly. Best fit is an expression. We have two things that you can return, yeah?
Okay. So
You
there's
can
best
return the
fit function
function
or best
or
fit?
the expression.
Okay, so fine.
Currently,
So that returns the expression, and then the question is,
actually it's called function alone, the one that is right now here.
I'm sorry, which one is function?
No. Right
Okay,
now you have two
let
properties.
me look at everything
Yeah,
that's
exactly.
there. What
Exactly.
what is this in? This is in
Linear model fit is going to be fine as a template for this.
where are these things? Okay, here we go.
There.
Oh God. What does it actually return in all these cases? Like ANOVA, what does it actually return?
Right now, a tabula. No, a dataset, sorry, because it's rugged. It used to be that you had like 5 different ANOVA properties. One with the table form, one
Okay,
with
but
the
I mean something like
entries,
fit residuals, what does it actually return?
a list. A list of
Okay.
numbers.
Data, what does that actually return?
The original data.
Why does it say all this stuff here? Why does it say
Yeah, I mean,
response
should say the
hours? What the hell
original
is
data
all this
probably.
stuff? What is all this stuff?
You have 2 ways to input the data here. Either like input outputs or a design matrix and response vector. And you can get out the
Okay,
data in the
look,
original form
this
or
is
the
a
design
giant
matrix.
mess. Okay, this whole thing. I mean, most of these are lists, right? Not expressions, except best
Most of
fit.
these are lists.
Except best fit is an expression.
Yes.
So why don't you separate out for me, which of these properties give expressions, which give lists?
By return type. Okay. Can be done.
Okay. And then of these, which do all of these give expressions?
No, I put it in the third column in that table. If you click on the notebook, you select it. Yeah.
What does
This
data
formula
mean?
and data.
What does data
I
mean?
mean,
A list?
data is numbers, is a list, yes.
It's a list, okay?
Yes.
So this is absolutely freaking incomprehensible. Because this bands thing is returning both the best fit and the bands.
No,
correct?
no. This is a
It'll
problem.
get the lower band and the upper band.
Exactly.
As a list or what?
Yeah, list
Yeah,
of
you
2
get
things.
a list of 2 expressions.
We didn't have anything else at the time.
But we don't have
Basically,
this. Where is
if
it?
you
This isn't in this list.
What?
yes, scroll down.
Oh, mean prediction.
There, properties of predicted values include.
All right. So what's the question here?
Basically, we need to add a new property that returns the around thingy, and we need a name which is not crazy.
Okay, but which thing are we extending to do the around thing?
It's a new property
Of
because we
best
didn't have
fit.
it before.
Sorry?
It's
Yeah,
a
I guess
property of
it's a
best fit.
decoration on top of best fit.
Yeah, I mean, maybe it's an around best fit or something. If you're
But
gonna fit
we need
with
a
this.
distinction between a mean and sample,
Well,
single or whatever.
Okay,
I mean, that's important.
well, so
We could have one small and one with a longer name.
Does that make any sense?
I see
Yeah.
where we're going. Yeah.
Would that work?
Yeah.
I guess. Let me run it through the more statistically savvy people in the team. But it doesn't seem crazy to me.
I mean, this will be basically the default. This will be the property that is picked out by plot.
Exactly.
Yes.
If you put a fitted model, I mean, plot has its own uncertainty option. Yeah. So if you do want the uncertainty, you will not have to switch it in
But
fitted
which
model.
of these will it pick by default?
We want the data one. Definitely.
Okay, I need to run. Okay, are we basically done with this review?
Yes.
Yeah, the rest is very minor, and we have an LLM graph review tomorrow where we can fold the text
Okay, all right.
semantic
Sounds good.
re-ranking.
All right, thanks, guys. And
Thank
I
you.
see Sander here commenting that he likes the fitted model on our live stream, commenting that he likes the fitted model design. Okay, we're not killing it. Don't worry. It's and Ahoy asks, will fitted model returned by local model fit also include metadata as to which
Yes.
underlying method was used?
Yes.
And I don't know whether we have a query thing.
No, right now, no, but I'm in the process of looking at this because given that fitted model is common for all the current blah 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 fit functions, all the documentation is in the fit functions. So the fitted model is a bit sparse. But we should definitely have a property that returns what type of fitted model is.
Yes. All right.
Like model type, something like that.
Yep. We do. We need that.
Okay. Sounds good. All right.
Okay. Thank you.
Till soon.
Thank